Hello, 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 everyone. We'll be starting in a few minutes. And yeah, shout out to everyone who's ready to learn because they said hey. No one said hi yet. That's a good sign. We'll get started in about 2 minutes. How can you see who's here? That's the whole reason I get y'all to say hey, so that way I can see who's here. How do you know Riley's here? Oh my goodness, you can hit participants. Oh, wait, maybe that's only the people in the chat. I don't know. Oh, that makes sense. Alright. Let's go and get started. And then we can, yeah, hopefully knock this out pretty quickly and be good to go. So, left off on Thursday talking about different possible cases for side angle triangles. Once again, side angle, even though it's always listed angle side, we don't say that, is whenever we have a triangle, we know that the first angle is 51. We know the side across from it, and we know the side between the two. Okay, so we know two sides in an angle. And the reason this is difficult is because it could be like this. It could also be slanted inward like this. So 51. It's a beautiful drawing. So there's two possible triangles. So we have to be able to find them both. Okay. So we're going to do law signs just like normal. Okay. So sine angle A over side A equals sine of angle C over side C. I have these two columns up here, just in case we do find out there's two possible triangles. So when we do this, we solve, and when you solve for sine of C, you get that you multiply both sides by 32 you get that sine of C equals 0.8289. And then inverse sine both sides. You get that angle C is 59.00. So we can go and fill this in as case 1. Okay, so angle A was 51, angle C is 56, side A is 30, and side C is 32. Okay. And if you remember where we run into trouble is because 56 degree gives us this angle, right? But we also know there's another possible angle where sine of C equals 0.82. That's going all the way to the other side. Okay, so what we have to do is we have to find out what that other possible angle is. And so we do 180 minus the 56. And when you do that, you get the other possible angle is 124. Okay, and so now we're thinking, okay, wait, is it possible to have 124 in this triangle? Okay, and the way we check that is we check 124 plus our angle A plus 51, and when we do that we get 175, and that's less than 180. So it is possible to have both these triangles in. So we do have a second case. Okay, so the way we know there's a second case is if the 124, that's our other angle, that's our C prime. I'm just putting in C prime as just a way to differentiate between two C angles. Or C2 maybe, you could say C2. Alright, with C2 and angle A, we have a possible triangle. So 124. What are your questions right now about figuring out if we have two triangles? Go ahead and type them in as I finish filling out this chart. Alright, hopefully someone will figure out a question about it. If I'm correct, you could see if this triangle if side C is greater than side A. I will look into that. That might be true. I will look into that. I think maybe not if they're close, or I'll look into that, Riley. It's definitely true on this one. It looks like it's been true so far. I will look into that. Because then angle C is greater than angle A, which means that's less than 180. Yeah, that makes sense. That sounds right. So if angle C is greater than angle A, that means 180 minus angle C will give you something less than... Yeah, I think that's right. But I will check for sure. Alright, so what we have to do here is finish finding the two cases, okay? And so we know 51 plus 124 is 175 because we did it down here. So that means the third angle has to be 5. And then we do the same thing for the case 1. We do 180 minus 51 minus 56 to get that this angle right here is 73. And from here we do law of sines to find our side B. And so we're going to have x is side B over angle B is 73. And that equals, I'm going to use angle A because it's the one we have. It's the one we've given at the beginning, so we know it's right. So x equals when you just multiply both sides by sine of 73, You get that x is 36.9. And then finally we wrap up with the other side, with the other case, excuse me. So it's x over, this time angle B is 5. And you solve that, multiply both sides by sine of 5. It's going to be a small number. And 3.4. We get that side B is 3.4. All right, we're going to put a pause on these two cases real quick and come back to it in a little bit. First, I want to talk about possibilities of having no possible triangles. Okay, so if you think about originally when we first introduced this, we drew the two possible triangles. Well, sometimes if I tell you the sides, so if I tell you this angle down here, and I tell you side A and side C, like we have before, sometimes side A is so short that it doesn't reach. It's impossible to have this angle with this side. There's no possible triangle here, because this angle tells us that this bottom side has to be coming out down the bottom. This bottom side has to be down here, right? And so with the bottom side and the side A, it's too small and it doesn't work. Okay. Example of that is this problem. Okay, and so just looking at this problem, we don't know if that's the case or not. So what we do is we solve it just like normal. So we set up lost signs. So we're going to say sine of 62 over 5 equals x over 14. Sorry, not x. That should be sine of x, or sine of b. I'm trying to find angle b here. All right. So we set up our lost signs just like normal. Then we multiply the 14 on both sides. So now we have sine of b equals 14 sine of 62 all over 5. And we plug that in our calculator. 14 sine of 62 divided by 5. We get that sine of b equals 2.47. Okay. And maybe alarm bells are already going off in your head, but if not, you keep going. You try to solve for side B, so you do inverse sine of both sides, and pops up, and you get domain error. Things don't work. Okay. If you think back to our unit circle, okay, the most any sine value can be is 1, right? So if you think back to our unit circle, perfectly drawn circle, right? Our maximum value here for sine is just 1. So if we try to find the angle at which sine is greater than 1, or sine is 2.47 in this case, that's impossible. If you think back to our sine graphs, we left those for a little bit, but no matter how far we go, the maximum our sine gets is 1. Okay? And that's how we know there's no triangle. Anytime you're going through, doing a problem, you've done everything right so far, and you try to throw an inverse sine, and when you do the inverse sine, or anytime you get a sine of an angle is greater than 1, that's where we run into a problem, and that's where we have 0 possible triangles. Okay? Yeah. Yeah, so this would be an example of a triangle that's drawn. This angle is 62. This side up here is 14. And it goes up, and it doesn't even come down far enough. So, for these next two problems, okay, I want you to try them on your own. I don't want you to solve the triangles, okay? I don't want you to solve. I just want you to tell me how many possible triangles there are. Okay, great question, Kyle. So, if sine of b is 2.47, okay, then we have no triangle, okay? So whenever we try to do lost signs, basically what I do is I just sometimes don't even think. I don't even think about my, like, oh, what if this, this, this. I just plug and chug in my calculator, okay? And then when I try to plug in inverse sine of 2.47, my calculator pops up and says, no, 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 don't do that. It says domain error. And then that's how I know that it is no possible triangles, okay? If we did get an angle here, okay? Say we did inverse sine of like 0.47, all right? Or something, and we did get an angle. Then we go in and check. All right, we have an angle. We know one angle is angle C is 56. Now we check to see if there's two possible angles. Two possible triangles, I mean. Yeah, two possible angles for C. Okay? So the first step is look, all right, do we have 0 triangles? No, we don't have 0. All right, do we have more than one? Okay? And so I guess to review, the way we check, all right, let me get to a slide. The way we check that there is more than one triangle, that there are two triangles, I mean. If there are two triangles, then we have this scenario where 124 plus our original angle is less than 180. We have the scenario where there is two possible angles for C. That tells us there's two triangles, okay? When there are 0 triangles, 0 triangles is whenever we get the domain error. And then 1 triangle is whenever neither of those happen, okay? So 1 triangle is you don't get a domain error and there's only one possible angle for C. All right? So what I want y'all to do here is you're going to go through and tell me how many triangles there are. I'm only going to give you like 2-3 minutes, okay? So your answer choices here are either going to be 0, 1, or 2 for both these problems. So yeah, set up lost signs, go through, solve for angle C. If there is an angle C, you know there's at least one. Then check if there's two possible triangles. I'll give you like 2 minutes to tell me how many triangles there are for these two problems. Not solving them, just checking. And feel free to ask some questions here. I'm not talking yet. I'm just setting up the problem. All right, so going over these two, we go through. For this first one, we're solving for, where's my mouse? There it is. We are solving for B, angle B. We do that, multiply both sides by 29, and we get 29 sine of 110 over 8 equals sine of B. So sine of B, handwriting is deteriorating as the day goes on. Sine of B equals, so 29 sine of 110, make sure I close my parentheses. Hate to see it, Kyle. 3.4, and we plug that in our calculator, or we see that's greater than 1, and there is no possible triangles, okay, or 0 possible triangles. All right, so there's our answer, 0 for the first one, because it's impossible to have an angle here. Do the same thing for the right hand one, multiply both sides by 35, we get 35 sine of 28, my 8s are awful, divided by 33 equals sine of C. Clean it up for you real quick, sorry. And so sine of C equals, running into where I did my thing earlier, .4979. So C equals 29.86. All right, then we check and see, so we know there's at least one triangle. So we keep going, we check to see if there are two possible triangles. So 180 minus the 29.9 gives us 150.13. All right, and 150 plus 0.1, is it possible to have a triangle that has 150 and 28 in it? We're going to add the 28, and we do, we get 178.1. So yes, it is possible. So there are two possible triangles. What questions do y'all have now about this? I'm just going to pause for another like 20 seconds for anyone to get a question in if they have it. All right, cool. So, this is just a little flowchart, okay? If it's overcomplicated and you understand what you're supposed to be doing and you don't want to worry about this, ignore this. If this helps you, great. All right, so first thing I'm going to do is this is just imagining that I've given you a problem and told you like angle A is this, angle B is this, side C is this, or some sort of problem where it's just like written out, it's not drawn. Okay. First thing you're going to do is you're going to ask yourself, is this law sines or is it law cosines? Okay. If we have an angle across from a side, we want to do law sines because it's easier. If we don't have that, then we do law cosines. All right, and once you have law cosines, then you continue on with law sines and finish the problem. Okay. So once we decide it's law sines, we have to ask ourselves, is it a SSA triangle? Is it like all the examples we've done in the past where there is where we have two sides of an angle that are across from each other? Okay. If it's not an SSA triangle, we just solve it like normal law sines. Don't worry about anything special. We just keep going. If it is a SSA triangle, we got to ask, are there 0 cases? Okay. So if inverse sine works, then we know there's not 0 cases. Okay. So I guess no goes here and yes goes here. Okay. So if inverse sine doesn't work, then we know there are 0 cases, and we put our answer as no possible triangles. If inverse sine does work, then we have to say, all right, are there 1 cases or 2 cases? Well, if A, just these can be any letters, but A plus B prime is less than 180, so B prime being that other angle, B prime being that obtuse angle coming out here. If A plus B prime is less than 180, then you find both triangles in 2 cases. Okay? If it is not less than 180, if A prime plus B prime is greater than 180, just keep going. You're done. Technically, if A plus B prime is 180, then it is also going to be only 1 case. But if you're getting that, round it a little less, and it should be okay. That's all I have for y'all today. These problems are kind of lengthy, and so that's why it's a little less. Your homework, I have some practice problems if you want to do them. But your homework, this is not right. Don't look. Don't look. All right, homework's due Tuesday because I pushed this back at 11:59 at midnight. There are, I fixed it though, Cal. I didn't goof. It's fixed. There are some problems in here that are, sorry. Let me regain my thoughts. All right. Homework. It is worksheet. It's already posted. You just go to Google, go to Classroom, Precalc Classroom, and classwork. It's already posted. It's 10 problems. If you're doing these and it's taking a really long time and you spend more than let's say 35, 40 minutes on this problem, on this worksheet, just turn in what you've gotten done. Don't spend more, let's say don't spend more than an hour on this worksheet. Okay? Because these problems might be a little long, and if they are taking too long and you're just not getting them and you understand how to do it, go ahead and just email me, turn it in what you got. I'll check what you have, and if you feel good, and we don't have to do any more. Don't do more than an hour on this worksheet between today and tomorrow. So 20 minutes today, 40 minutes tomorrow. That's all you need to do. Next live stream will be Wednesday. We are going to talk about area and talk about a potential project I'm going to give y'all instead of, a potential project we're going to do. So, I'm going to stick around. If y'all want to do some of the practice problems together, we can do that. If you want to do some of the worksheet ones together, we can do that. If y'all want to just log off and say, I'm good, I got this, I'm going to go practice and email you my questions, we can do that. And, thanks for coming out. Yeah. See y'all Wednesday. Don't worry about filling out the survey. Don't fill out the survey either. It became clear that people weren't filling it out anyways, people who are in chat, and then I can't give people credit when I know that not everyone's filling it out. even the people who I see talking the whole time. So, oh well. What do y'all want? What do y'all want to do? I'm just chilling. If y'all want to do practice problems, let me know. If y'all want to do look at some of the worksheets, let me know. Y'all want to talk about life, let me know. Yeah, I'll post the PowerPoint. Absolutely. Yeah. All right, y'all, I'm gonna go ahead and end the stream. Thank y'all for coming out. Feel free to email me and ask questions. And tomorrow all I'm doing is grading papers and preparing for Wednesday's lesson. So if you have a question anytime there, let me know. And yeah, see y'all Wednesday.